Let's go over how to factor 9x squared minus 69x plus 90 using trial and error. So the first step is we look for some kind of factor we can take out. So let's start by doing that, and I see a 3. And I would say this isn't technically required, but it's so much easier to work with smaller numbers than with larger ones, so always try and do this first. But make sure that you don't forget this at the end, that you took this out. So that 3 is going to need to be attached to what we do next. So for trial and error, you're essentially just trying to fill in the blanks. We need to have something that looks like ax plus b and cx plus d. Now, a times c must equal whatever is in the a term. If I can get my pen to work, the a term. So a times c has to equal 3, and b times d has to equal whatever was in the c term. So that must equal 30. And we can kind of see why that is, because if we want to end up with a 3x squared, then whatever is in the ax and the cx, that has to end up being 3x squared, and the only way for that to happen is if a times c equals 3. Same thing for b times d. In order to get a plus 30, then the two terms that don't have an x on them have to multiply out to 30. So now we know that a times c must equal 3 and b times d has to equal 30. And then the only other thing that needs to happen is that once we create our middle term, it has to end up at that negative 23. So with trial and error, you kind of have to, try and see if it works and then try again. Now, the good news is that with a times c needing to be 3, there's only 2 options. It can be 3 and 1 or 1 and 3. So that's a little bit simpler than if you had an a term that had a lot of combinations. But for the b times d equaling 30, there are a lot of options, because you can make a 30 as 1 and 30, 3 and 10, 5 and 6. So there's more trial and error there. But let's just start off by saying, let's say that we have 3x plus something and x plus something. And I'm just going to start by saying it's 10 and 3. So I multiply this out and I get 3x squared, of course, plus 10x plus 9x plus 30. So because we did the a times c math correctly, we do get the 3x squared, and we did the b times d math correctly, and so we're getting plus 30. But plus 10 plus 9, that does not get us anywhere near the negative 23. So 19x is not equal to negative 23x. So we know that we haven't gotten it right yet. So we try another one. 3x plus something and x plus something. And let's do negative 10 and negative 3. So we again have 3x squared minus 10x minus 9x plus 30, and that's not going to work because that's negative 19x. So we can see here that if it doesn't work when both are positive, it also doesn't work when both are negative, because they just end up as the opposite number. So if we had come up with something that gave us a 23x, we would know we were really close, and that perhaps we could just turn the positives to negatives. But here we're not even arriving at the right number. So let's try another combination. 3x and x. Let's try 6 and 5. Plus 6 plus 5. So we have 3x squared plus 6x plus 15x plus 30, and that is still incorrect because 21x is not equal to 23x, or sorry, negative 23x. So we just keep working. 3x, let's see, it seems like we need to use negatives here since we need to end up with a negative 23. So let's say 3x minus 5 and x minus 6. Maybe that will work. So 3x squared minus 5x minus 18x plus 30. And now we have minus 5 minus 18 is negative 23x. And that equals our goal. So we have the right answer. So that means that we have 3x minus 5 and x minus 6, but we cannot forget something very important, which is that we factored out a 3 right at the start of our work. Put that right back here on front, and we have our answer.